Sorry, I think I forgot to record this session half. Okay, so let's discuss about what probes and agents within servers. Okay, so this approach is classified as white box testing. You already know that this is why product really agent calls it probes embedded NAS. So this is a terminology NAS because that's inside the server. So Relay agent is a product which monitors the server, which has its own agents deployed on the servers, and they call them as a NAS. Okay, so after a probe is instrumented to recognize methods using on its application server, it makes an announcement whenever it detects invocations of servlets, JSPs, EJPs, JNDI, JDBC, everything, right? So whenever your probe is instrumented, like for example, if you are aware about the HP Diagnostics app, right? So most of the time HP Diagnostics will be used to monitor either a Java probe or a .NET application. So these are very favorite diagnostics is used for HP Diagnostics. So whenever a probe is instrumented on a Java application server, and when client is accessing this application, when the client traffic is going to the application, and as soon as the EJPs are triggered, the servlets are triggered, JSPs are triggered, you get this recorded on your diagnostics tool, right? So this is how this instrumentation is done, and the level of instrumentation you can decide at the time of configuring the server, right? So this probes report on JVM memory heap uses and the memory consumption of Java collections, everything. So this is how this internal server monitoring goes, which involves in either probes or agents to be deployed on the server, which has to be monitored. Okay. Okay, so MS Windows system monitors. Now let's see about the Microsoft Windows system monitors. So most of the guys or most of us already know the Windows monitors and what are the things that are there in the Windows monitor, right? So there are several ways to read performance data. So task manager list, measure. Yeah, task manager is the important, the most the first thing you come to your mind when you're saying monitoring the Windows system, right? So system monitor, MMC snap into the performance console. So system monitor is the old name. So in Windows 2000, it got renamed to the perfmon. Nowadays we know it as a perfmon. So earlier it was a system monitor tool. So the Windows used to call it as a system monitor. So it is now a perfmon. So same way we have the system monitor, we have network monitor also. So network monitor does the same task that perf monitor does for the system. Network monitor does for the network. So it will collect all the data from the NIC card, right? And performance logs alerts can be configured on the Windows as well. Logs, which can be later analyzed using the different types of tools. So servers configured with the simple network SNMP agent, and why these are not you know important to nowadays, because we have a lot of sophisticated solutions, APM solutions, right? So earlier days we didn't had this many application performance management tools. Nowadays we can Dynatrace and App Dynamics are so powerful that they can actually give you the uh, entire data about your server, right? What are the processes running on server, what everything about your server they can give. Earlier it was not that simple, so you have to you needed to configure it on your own, right? So there was some kind of application response measurement API. It's a C and Java programs. It was written in the C and Java, which was to measure the application availability, performance, and uses and end-to-end transaction response. So this was the earlier time. Nowadays it's very simple with APMs. Okay, so this is some basic image. I hope most of you might not have seen this. At the left side you can see this 42%, and there is some red color to the utilization the CPU uses. So this is nothing but the kernel uses, right? So out of this 42%, you can see maximum percentage being used by kernel, right? So why it is important? We will discuss it later. The kernel uses. Okay, so the sample screen shows both your kernel times because it is selected. You can see this show kernel times checked, right? So that's why it is showing you the rate. You can actually try this on your system if you are on front of system right now, or I can show you right now on the task manager. Okay, so mine is Windows 10. So I need to find out where this option is now in Windows 10. Update speed is there, but kernel view is, I think, not there. So if you guys are working on a Windows before Windows 10 version or Windows 7, you can see that. I think I need to find out the specific on this Windows thing. How we can see that. Okay. Okay, so this is basic things, and there is, you can see the CPU speed, update speed is also there, right? So what is this doing is that it is by default set to normal. So the graph you are getting plotted over here, right? CPU users history. This is the speed. The option we are checking over here, update speed, is tweaking this graph speed, right? So how it will help is, so when you do update the speed to lowest category, you can easily see the cycles, the process which are hogging the CPU, right? The CPU, because let me just show you the task manager. Right now, if I go to the performance tab and I can see the CPU is going up. The same way, if I go to the processes and I just click on CPU, the top process, you can see that it gets changed. You can see that system is coming up, then Windows, then Task Manager. So I'm not actually able to identify what is actually hogging on the CPU cycles. So which process is actually required to have more cycles to work on. So what I can do is I can just go to the performance tab, leave CPU, update speed to the lowest. So when I do this lowest, you can see that processes, whatever the processes are there, they will also start hogging slowly. So you can analyze, you can see this Windows audio devices up, then Windows Task Manager is up. So in that way, you can identify a process which needs higher CPU cycles, and then you can simply right click on that process. You can assign more resource values. So resource values memory, then disk and network. So you can have you can increase the priority for that particular process likewise. Okay, so that's why it is that's how we can use this update speed update speed functionality in your task manager. Nowadays no one does that, but I'm just giving you the information that we are how it was done in the earlier days. Nowadays you can already get this data by API. Okay, so MS Windows System Monitor, that's Pokemon that we already know. You might also know that Pokemon is this data display is it's immediately. So most of us already know if we are using Performance Center or if you are using Application Lifecycle Management (ALM). So we have some counters over there, right? The servers and counters. So these counters are actually the Pokemon counters. So they are actually talking with the Pokemon on that particular host or that particular server that we are trying to monitor. Okay, one more thing, one more functionality of Pokemon that you may or may not be aware of is that you can actually get this Pokemon in a specific Internet Explorer graph. Okay, so I will just quickly open the Pokemon. Okay, so this is the resource monitor. Administrative tools. And we have Pokemon. So as soon as you click on the performance monitor, it starts gathering the metrics for you. Like you can see like that in the system summary, it starts picking up the metrics. You just click on the performance monitor. Now, because there are no metrics selected, you cannot say anything. There's just a normal graph of the processor time, percentage processor time. Okay, you can add the metrics from here. So I need not to teach you all these things. You might already be aware about it, right? So I'm just showing you how this information can be used. When when you are left with no choice, when there are no tools at all on your application to monitor, so you just right click on this perf mode, this save setting as, let's say in the documents, giving as a test processor. Okay, so I'm saving it as a test processor.html. Now it's in the documents page. Okay, now this is my html file. I just when I just double click it, okay, so you can see this live monitoring once this file is open. It is not able to. Okay, so because it's running on ActiveX controls, you can see. Okay, so you can see this live monitoring over there. So this is helpful when you don't want to expose the entire system or entire host to the third party vendors or to third party systems to monitor. So you can give a specific, you can collect specific counters, you can correct your user defined profile, and you can just export these settings as HTML, and you can share it with them if they are, if they can connect to your server like that. So this is the way you can also use this pop mode. I hope yeah, this is something an additional information for you, or if you already know it, it's good. Okay. Okay, now let's come to the Unix system monitoring. Okay, so how Unix system monitoring does in Windows, we already have perform, right? So yeah, so to answer your question back from the previous slide, Chandan. So as I said that there is an open source tool which can generate the alerts. So this is the tool, Nagios. Right? You can actually access it. You can go to the tool and find out the different types of options available for scheduling alerts and all these things. So this is Nagios. This is completely open source. So system monitoring, protocol monitoring, application monitoring, database log. So everything can be done, right? So this is a free tool, Nagios, but few of the processor or few of the parts are only billable or only license based. Okay. Okay, so we are specifically discussing about Sidescope because Sidescope is the first tool that was introduced by HP for Unix system monitoring. There were the tools were available like N1 and all those things, but they come later. So Sidescope is the only tool that can be that was available at that time. So it was again agentless monitoring software. It focused on monitoring the availability and performance of your all the distributed IT infrastructure like servers, network devices, services, application components, OSS, and various enterprise components. Okay, so even it is agentless tool, because how agentless tool works, we saw that in the previous slide, right? Two types of monitoring. One is the probe and agents, other is the agentless, the external. So they send commands, right? So you can find, if you have the site scope set up in your environment, so you can find this file, sitescope slash templates.os. So there are some Unix commands, or there are Windows commands depending on the OS of the server that is being mounted. So these commands are triggered for the server to be mounted, and it is collecting the metrics. As I said, the sitescope exerts about a 10% overhead on servers responding to the remote queries. No, however, it duplicates the same request made by load runners Unix monitors, hitting servers with twice as much monitoring traffic. So if load runners Unix monitors are hitting servers for 5 seconds, so Sitescope will hit 2 times in 5 seconds, right? So perhaps for this reason, the Sitescope monitor has a default measurement update range rate of once every 10 minutes. So this is a very tool specific information. So it has to be, set default range has to be set to the 15 seconds in order to get some data in the control graphs. So when you are using, so HP used to sell this as a bunch, the software initially when the load runner version was 9 or 10 something, 9 point something. So at that time, HP used to sell Sitescope as the, licenses for Sitescope as predominant. That time Sitescope was newly introduced, and as a monitoring tool, HP used to sell Sitescope licenses to the customers. Okay, so now let's go to some basic commands. So these are the commands, guys, you can actually try if you are if you have some handy Linux server. So as of now, I don't have any Unix box set up on my machine or my laptop, so I cannot show you this commands. Okay, but these are the some status commands. Uptime, which provides instantaneous summary, like how much time the server is being up. So you can say this particular server I tried this command on. It says it was up 698 days. What was the time it started? What is the load average and all these things, right? And you can see the after load average there are three values: 0.48, 0.26, and 0.20. So this is the load average for the first minute, last 1 minute, last 5 minutes, and last 15 minutes interval. Likewise, okay. Uh, so let's also understand what is load average. So this is a very misconception in most of the performance testers, and throughout I've seen. So if I ask what is load average, they will say that average load put on the system or average load on the processor. So it's not that the case. So load average is the average number of processes, the sum of queue length and the number of jobs that are currently running on the server, right? So this is the average number of processes that are ready to run but are waiting for access to a busy CPU. This is the load average, right? So you understand this concept, because if you don't understand what the metrics is giving you, you will not be able to correlate it with the any specific performance objective of your application, right? So what is load average? It is the average number of processes which are uh, ready to run, but they are waiting for access to a busy CPU, right? There are different cores of CPU. So 1 2 3 4 0 1 2 3, like that. Likewise, we have in Unix. So if the load average is 0.48 on 0 CPU core 0, that means the 0.48%. So 48% of processes assigned to that core are waiting to be executed, right? So as a general rule of thumb, a machine is being overworked if load average consistently exceeds 3 times the number of CPUs. So that is some important information over here. If your load average is exceeding the thrice of the number of CPUs, you have 4 CPUs, and if your load average is going beyond 12, so it is a sign that your system is CPU savvy, or it is starving for CPU, or it is overworked, right? So that's how you identify. The simple commands, simple Linux commands can give you this kind of data, right? Top command, all of you know how the top command provides. It provides again the load average with auto refresh and additional data, right? So this uptime will give the only single line output, but top will continuously refresh this data. So I've just pasted out the screenshot from my one of the my box Linux box from back from the office. So you can see the top command is giving load averages. Again, this is 1 minute, last 1 minute, 5 minutes, and 15 minutes intervals. Okay, so you can see that there are different tasks total 1017. So on few of the servers, it is defined as processes, and one is running, rest are sleeping, some stop, 15 zombie. So we will understand what are the different this terminologies. So what is zombie process, what is running, what is sleeping, right? CPU we can say 0.4% user, 0.3% system, 0.0% idle, 99.3% idle, right? Memory, you can see total memory size, what is used, which is free, what is used in buffers, swapping you can see. So this information is easily available with this commands. Okay, so on the Solaris OS we have the PR stat command. Same info what we get on the top. This is, I think this is SUSE, Linux SUSE 11, and on the Solaris you get this same information with PR stat command. There are some different flavors of Unix, and there are different flavors of commands also. So some commands may work on some OS, some commands may not work. So PR stat is the alternative for top command on Solaris system. Okay, so when this top command is running, you can just click on MP on Q to identify to get specific memory, CPU, or stop displaying the top entire output. Okay, so there is next command, proc info. So proc info is nothing but the processor information. So this is actually under the systems data directory, which is which updates in every 30 seconds. Okay, so this what kind of information it gives? It gives you this last the listed information below. The last boot time, the load average. Again, we know what is load average. So average number of jobs running, number of runnable process, total process, PIDs, swapping information, memory resources on the server, number of disk, IRQ info, installed modules with a hyphen A or hyphen M option. So you can use proc info hyphen A or proc info hyphen M for modules. Hyphen A will give you all, hyphen M will give you the specific modules. The also file systems are there. XOS provides a constantly updated color for summary view of various components. Now this XOS is not available on the Linux box, or I think it is deprecated from few of the last few releases. Okay, so this is important. RStat. You might have heard about it. You might know about RStat. This daemon is a server, which returns the performance statistics obtained from the kernel. So what is RStat? It's the remote statistics. Okay, so this is a daemon service, right? It runs through inetd. So we will come to that how it runs. If you guys are more interested in how do you configure the RStat, I can also show that. So this is a specific daemon server which returns the performance statistics obtained from the kernel. So in just for your understanding purpose, in layman terms, you can call it as a perfmon of Linux, right? The same way like we have the perfmon on Windows, you can call it the perfmon on the Linux, but it is remote, right? So from one server to another server, you can collect the matrix from the another server through RStat. Okay. So what are the statistics that are varied by RStat? So you can see that collisions rate, paging rate, average load, swap out rate, and CPU utilization, disk rate. So what is collision? The collisions per second. So package collisions. What are the number of packets, incoming packets, outgoing packets, the packet rate, and the collision. Paging rate, number of pages read to physical memory or write to the page files per second. So this is the information that RStat collects. Okay, then same way RStat we have some SR. So likewise RStat is for collecting the remote statistics from the server. SAR is the localhost. I mean, you can use the SAR command to get the entire statistics of your server uh, on the local server. So it can be run either as an interactive command or as a background service. If you want to monitor your server So you can just run it as a sar-a. You can see this command I mentioned earlier. Sar-a-o. You just give an out file name, and this is the interval. This is the frequency. So the five samples every 5 seconds, 200 samples. Okay, okay. So this is the way SAR gives you lot of information. So system activity report means everything that is being done on your system, like right from the CPU consumption, right from the number of processes are running, right from how many sessions are logged in on the Unix box, how many shells are open, everything will be given to you. This SAR, it's a huge amount of data. You need a specific tool to analyze the data and get some understanding out of it. Okay, so the back so that this is the next. The background report package can be enabled by uncommenting the appropriate lines in the cron tab. Okay, so I think you might have heard about cron tab, or you know the cron tab, right? On the Unix box. Do you know the cron tab, guys? What is cron tab? Okay, so you know the task scheduler, right? Windows task scheduler. We have a Windows task scheduler. The same way it is the replica in the Linux system. So the same way that we have a task scheduler in Windows, we have cron tab in Unix. Okay. So, but it's slightly complex implementation of scheduling the jobs or the cron tab. You have to mention some specific dates, parameters like dates, time, and everything. The frequency of this job has to run either if it is a one-time job or it has to be run redundant. So this is just in the short way. Cron tab is the alternative to the task scheduler in Linux. Okay. So under the cron tab, you need to edit this file init.d, which writes so you can get the report out of the SAR out file. So you will if in case you are exposed to the Unix box in your office or in your premises, or if you have Unix system at home, you can try this command. Just first try it without an out file. Just type sar hyphen capital A and 5 2000 and see what is the data coming, right? Then you try it out file and try to get some information out of it. Okay, so there is super user command, so which will update which will give you some daily data file using this command. So it is using this SADC. It is the data collector. So SADC is nothing but your system activity data collector. So the command, you can see that it is also appending the date and format on which so date wise you will get this information. So on the Solaris, this services SVC systems are default, which reads the same keystat and data and IO static. The same way, I mean, the same system, same implementation is available on Solaris as well, but at the different location. Okay. Okay. So now we are coming to end of the slides. Other monitors. So what are the other monitors available? So most of the time people don't know about it. Whatever I've interacted in the industry. So Quest Spotlight, it is an excellent SQL Server, monitoring tool. Quest Spotlight. So all the SQL Server Enterprise offers this dashboard. So it is actually taken over by SQL Server only. So this provides a visual approach to organizing metrics. So most of the time you have used the Oracle, right? So for Oracle databases, you have Oracle Enterprise Manager, OEM. Same way for SQL, you have this Quest Spotlight. You can see the screenshot below. Here you can see the different types of information is the system, network, this NBT, CPU. this memory paging file. So this one is from a very old version I had. So nowadays it is more organized and more tiles. It has more information inside. So all the instances of this database and the instance efficiency and a lot of data is there nowadays on this dashboard. So these are the some other monitoring systems or other monitors that you can use or that you can imply to measure the performance. So VX stat utility is there for HPUX OS. Then you have measure where agent in HP's OpenView network measurement suite. Now HP's micro focus. So this is also, I think, measure where is also deprecated now. I think they are not using it anymore. Sorry. So Popmon we all know. Popmon agent is there, and that's all right as of now today, guys. So tomorrow will be more interesting because we will be seeing that the particular uh, let me just show you the agenda. So tomorrow we will be seeing, different types of major objects and what could be the possible issues and how do you identify by measuring what metrics. Network, there are n number of metrics available. So in demo application, Chandan, I can show you for the Windows. For the Unix, we need to check if we can set up something on VMware, or if the Sigwin can work. You see, I have Sigwin. I think I don't have installed it here. With Office. Okay, I will check it out, Chandan. So you can, you can get some hands-on for these commands. So some basic Linux commands. So we will try to make a demo, training demo for this. So let's just first get on this. What we are going to see tomorrow. So tomorrow agenda is to see measured objects across network, memory, server queues, threads, processes on all CPUs. Then there are some other measurements. What are the different types of log file formats? How a threshold is how thresholds are defined to trigger an alert. Then understanding the latencies, server, network, client latency. Then J2E monitoring, and I will give some 2-3 questions end of the slide, just to just for you to work on and recollect the things that we have discussed in this 2 sessions. Okay, so I think we are done for this, guys. So any questions, specifics, any suggestions, please let me know, or otherwise we are good to conclude.
Hi Chetan, this is Chandan.
Yeah, Chandan, tell me.
Okay, can you go to the agenda one?
Yeah, sure. Yeah, tell me.
Okay, so this is just an overview on the monitoring side, I guess.
Correct.
And yeah, so tomorrow, whatever the counters you have mentioned on agenda two,
Hmm. Right.
so those are like you will show us practically on any application or how it will be.
Practically, because these counters, Chandan, are very generic. I mean, uh, generic to the OS specifically, Windows or this. So whatever the Windows counters are there, I can show you. But for Unix counters, I don't have a Unix machine on my laptop. So what you can do is, if you are, if you are working somewhere, or if you have access to Unix boxes, I will list out this all these commands, and whatever the slides I have mentioned now. I have list out all these commands. I will mail it to you guys, so you can try it out on your own. And if you face any issues, any difficulties, let me know. I will try to solve. So
No,
as far as this
let's say
demos,
like
yeah,
let's
yeah,
say
tell me.
network.
Mhm.
So you will give us some commands based on Windows and Linux.
No,
Accordingly,
no.
we will try.
So no, no. So tomorrow's session is not about commands. So it is about
Mhm.
what you are monitoring and what could be the possible issue. What should be the threshold. So it is a tabular format. So I mean, I have it in mind. So I have not actually prepared this slide. I will prepare it today. So what is
Okay.
the net? And network is a very generic term, right? So what is the important metric that you should focus on network? and what kind of issues you can identify using this metric. No, so as a performance engineer, you need to understand the correlation between your metrics and the problems, the bottlenecks, right? So the role of performance tester is just to identify the bottleneck, but when you come to performance engineering, you should also be able to identify that this particular bottleneck can be identified with which metric. So to dig down, so deep dive, and to have more analysis, you also need to understand what are the different things, in the consecutive test or consecutive reruns you are doing. So what to focus on, what to monitor, right?
Okay,
So we
I
will see.
understand.
Yeah.
Yeah, I understand what you're saying, but my question is, how can we capture those metrics?
How can we capture those? I mean, you want to say, you want to see the live capturing, or how?
Yeah, so let's say you mentioned network.
Hmm.
So how, like in, like, even we get to have the correlation or like whatever you mentioned. So how can we capture those metrics? My question.
So I will also show you that. So I will give you the complete name of the counter, right? I will also
Okay.
show you that where you find this counter, how do you monitor it, how do you add it to your
Okay.
monitors. I will show you that.
And all these monitors, whatever you mentioned, so it is related to which server? Like it is on app layer or web layer or database layer. So like which layer or which server you are targeting for?
So whatever monitors we have seen as of now, right, Chandan? So these are specific to the OS. As I discussed at the start of the session. So there are only two popular OSs as of now. One is your Unix, or another is your Windows, right? So it may be your Windows server, it may be your Unix server. So the server where it is used, if it is used as an application server, that will be your application server matrix. If the server is used as a web server, it will be your web server matrix, right? So this application, web, and database, all these are the what we can say, the functionalities, or these are the rules given to the server. The basic server, the baseline server is the same, the OS on which this is running, right? Either it is Windows or it's a Unix.
Okay.
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 So any other question, guys?
Yeah, yeah.
Yes,
Please.
Anna.
So, is it what we refer to as bottleneck analysis under what you're gonna actually teach us?
Yeah. Tomorrow we will be seeing that's bottleneck analysis. So using this measured objects, that is in the agenda 2, we will be able to see that how do we use this counters to analyze the bottlenecks, and what kind of bottlenecks are measured with these counters. We will see that in tomorrow's slide.
Okay. And when they talk about this performance engineering aspect, they say analyze the bottleneck.
Mm-hmm.
What the word analyze there specifically mean? Is it to
Sana, your voice is breaking, Sana.
okay? You talked about we're gonna know you're gonna teach us how to analyze those bottleneck. So analyzing bottlenecks mean you try to actually pinpoint where that what it means by
Yeah, so actually the analyzation part, right, what you're talking about now. So this is, first we are learning the things now, right? So the implementation will come after. So we will have some demo application where we will do everything that we do as a performance tester, and we will see, we will create some scenarios, some dummy scenarios, which will cause some performance issues, and we will see that how we can analyze it, right? So we have that plan, but before that we need to have these concepts clear. We need to understand what are the network counters, what are the memories, right? What to monitor, that we need to first understand, right? So we will see that how to analyze it, and the subsequent upcoming stations we will see that.
So you mean to say like you will cover all these counters, like how can we analyze on those applications?
Not all the counters, Chandan, entirely, but I can give you a rough idea. My job is not to teach you everything. My job is to let you start this thought process, so you can explore on your own. You can learn these things, that how do we do it. So I'm just guiding you that we will have a demo application where we can consider, we can implement some dummy scenarios where we can go through that scenario. We will run that scenario through JMeter. We will create some performance issues. I will show you everything. So I am not prepared the process flow, the workflow, that what type of performance issues that we are dealing. But if I already tell you the performance issue, that we are going to identify this issue, it doesn't sounds interesting, right? It has to come through that working purpose. So when you are saying the demo, you should actually go through it. You will also have to set up all these things at your own desktop and at your own laptop, and so that you can get a hands on it. Okay.
Oh,
Okay,
hello,
guys. Yeah,
hello.
yes or no? Yeah.
Since you didn't actually recorded some of those very important slides before you close this section, you want to please check on one of some of those slides one after the other without even explanation, so that we can see that one when once
Okay.
you understand what I mean. You didn't record most of those important aspects at the
Yeah,
start of
yeah,
until when I
yeah.
alerted you. So if you could go through
Mhm.
the slides one after the other so that we can see the screen, that would be really
Yes, yes,
helpful.
yes. Yeah, so I can quickly summarize for you, Shano. So
Mhm.
we saw the performance monitoring. So what are metrics monitoring and alerting? So we understood what is a metric, how it is compromised, right? Uh, and how metrics collects the raw data. Monitoring is the process of forming this raw data to the collecting this raw data and creating the out of it, visualization out of it, right? Then the next slide we also saw what are the metrics and why do we collect them, right? So it is data versus information, you can see. So these are the basic values to understand historic trends, correlate. Why do we collect them? So to understand the historic trends, correlate diverse factors, and measure changes in the performance of your application. So and sorry, consumption of error rates. So we also saw that metrics are divided at the two main level. So the low level metrics and the high level metrics. What is the low level? The which is easily available by your operating system, or which is provided by your operating system, such as the CPU utilization, memory utilization, network IOs, disk reads, disk writes. Yeah, so this is already provided by your operating system. These are the low level. High level metrics comes with the server specific or application specific or the functionality specific component, like the number of requests served by the web server, right, per second. The number of threads are available for the web server to serve on. So this is the high level metrics, right? Then we saw this what is monitoring, right? So as we already discussed, this data versus information. So metrics collects the data, you know it collects the data. The information monitoring does generate the information. So if collect the metrics for a particular duration, very small duration, let's say 5 seconds, 1 second, 2 second, it will not give you some insightful information, right? So for to have information, you have to do aggregation of this metric. you have to do you have to store this metrics for a longer duration, and then it can be visualized, can be processed. Then what is this process? The aggregation and visualization, this process is called monitoring, right? So why what is the I mean what monitoring systems are typically do, they typically provide the visualization of the data that has been collected by your metrics, right? And then we saw the alerting. What is alerting and why it is important? So uh, nowadays we have this data storage facility for monitoring tools available. So the person who is actually monitoring can stand away from the system because we have the historic trends available, right? And he can schedule some alerts for specific thresholds or specific conditions. Let's say for CPU going reaching 80%, memory utilization going 75%. So at that time only the respective teams will come in the picture. So that's why this alerting is important. Okay. Then we also saw that KPIs. These are the listed KPIs by Stackify. So you can see this user satisfaction or application performance index score. So this is a very nowadays very popular API or KPI about which talks about the application satisfaction score. So how does it calculate it? So it segregates the web request in three categories. First is the fast request, which meets your SLA with that gets into the fast category. Second is the sluggish category, which is slightly beyond your SLA. The third will be the too slow, which is breaching your SLA, right? And there is a formula that application index can derive, like satisfied count plus tolerating count by 2 divided by total samples, right? Then next we saw that average response time and how it is not good to report average response time, right? So we can see from the image in the screen, both of the graphs are having same averages, but both of the graphs are reporting the different application behavior, right? So first graph is saying that is the response time of application is very much in proportion with the user load, and the second graph is saying it's inverse, right? At the start of the your duration, it is high, the response times are high, they are coming down in the middle, and then again they are increasing. So these are the two different variations. That's why average response times are not good to judge the performance of application. So you should always use 90% response times, or you should use the satisfaction index like abdex scores. Okay. Then we also saw about the error rates and count of application instances. So why error rates are important? So we also discussed about that how error rates are segregated between the HTTP error percentage, logged exception, and thrown exception. I've also given you an example of how the exceptions, number of exception can cause adverse effect on your application. I give you an example that for a particular application that I tested, the scenario was perfectly working fine, but there were a number of exceptions getting generated. So how that had an effect? So this exception did not cause any harm to the transaction response time, but it caused the harm to the application JVM heap. It left the stack trace untouched, so that was that consumed the heap area, and eventually the application got crashed. So that's why error rates are important. Then we also saw about the count of application instances. So when we nowadays it is important to monitor this count of application instances. Why? Because nowadays most of the applications are deployed on cloud, and they are on auto scale. What is auto scale? So if your application if the application requires high CPU, if the application requires high memory, the infrastructure, the cloud infrastructure will automatically detect it, and it will automatically add another application server or another database or another memory component to the infrastructure. So why it is concern? Because when your application is demanding the CPU, and you don't know the exact cause why it is demanding high CPU, and the infrastructure is automatically adding the another instance at the monitoring level, you will not be able to see the CPU spikes. You will not be able to identify that there was an issue. But you can see certainly that count of application instances gone up by one. So that is why it is important to identify, to monitor this also, right? Then there are few basics. Request rate is there. So what is the rate of request at which the web server is being heated? So it is also important counter, which also affects the different application criteria. Like if the request rate is high, ultimately your CPU and memory utilization will go up, depending on the how much processing power it requires to process all these requests, to serve all these requests. Same way, application and server CPU, we already know that is an important KPI. Then application availability. So we also discussed about that. Monitoring nowadays, the organization promise most high availability applications, right? So we have this. We have to monitor this application availability. How do we do that? We can simply send a HTTP request to the all the business specific models of an application, or we can use the tools like HPBSM. Okay, business BPM, business process monitoring. So which has the complete setup to test application availability. Then garbage collection is the all famous tool, all famous counters. We know that that is an important KPI. Then we also saw this monitoring types of monitoring. I think from this point we started recording, right, Shana?
No, we started monitoring. Um, there was a particular slide I can remember when you read here. That
Okay,
was started monitoring. Maybe
okay,
two
okay.
after
No
this.
issues. No issues. I can just summarize it. So we saw the types of monitoring. So what is internal, what is external? So there are two types of basic. So internal is the agents and probes within the server. Then the external is when you are sending specific commands out to the server to get the response. In the response, you are expecting the utilization and the metrics, right? So these are the two basics. Under the external, we also saw that the resources used by server in the Java or .NET application that can be uh, monitored by the commands, right? So that's why it's called as a black box, because there is no communication, there is no nothing inside the server. It is everything is outside the server. That's why it's a black box approach for monitoring or testing. Okay. We also need to understand, though it is an agent-based monitoring, the external monitors, it doesn't mean that it is not non-intrusive. That means it has some additional overhead, even though it is an external monitors, because when we are dealing about the request and response from the servers, in order to get some metrics from the servers in return, so it adds some external ad hoc overhead on the servers, right? Then we also discussed about the internal monitors. What are the different types of probes and agents that can be done, and it is called as a white box. Sorry. We also discussed about the instrumentation, how the HP diagnostics tool is instrumented, and how it can monitor the different types of JVMs, sorry, JSP and EJBs when the particular application server is targeted by client. Okay. So next slide we discussed about the Windows system monitors, right? So it is some historical monitors like all the Windows system monitors. Earlier it used to be called as a system monitor in the system. But later than Windows 2000, it was renamed to the performone. Right? Performone gives you all the graphs and all these things. So it is again objects. It is ActiveX control based, right? So earlier days they had application response measurement APIs. Nowadays we have the APM tools, right? Earlier they had this SNMP protocol agent to be configured to to monitor the network tree or the messages, or to analyze the messages coming onto the third party SNMP system. Nowadays we have a more sophisticated way of doing that. Okay. Then we saw that basic task manager thing, that the kernel uses, how you can enable the kernel uses. You just need to change the go to the view in the task manager and just update, just tick the show kernel times. It will show you the actual CPU used for the kernel processing. Then we also saw that the speed, how you can use the update speed graphics counter to identify the processes which are hogging on CPU cycles. Okay, so I also showed you like that. If you set it to low, you can check the processes which are taking time, which is CPU savvy, which needs more cycles to process, and then you can specifically right click on that process. You can increase that process's affinity. Okay. Then we also saw about the performon, the basic MS Windows system monitor, how it can be used. We also saw that we can export the performon settings to an HTML file, and that HTML can be shared with the third party vendors or the other peoples, and they can monitor the host live, right? And we can also restrict the amount of counters that we want to share with them. So in order to maintain the uh, secrecy, or in order to maintain the security of your host. Okay. We see also the next Unix monitoring. We saw that Nagios is an open source performance monitoring tool. Then specifically we discussed about the site scope, how Sitescope is working. So even though it is an agentless monitoring tool, it has about a 10% overhead on servers which are responding to the remote queries. Okay, so where are these remote queries? So all these remote queries are defined under the Sitescope installation folder slash Sitescope slash templates.os. Okay, so all these Unix and Windows commands are there, which the Sitescope queries to the respective server, which has to be monitored through Sitescope. Okay, and we also saw that Linux status commands, that what are the different types of commands that we can use to get, say, the Linux information uptime, which gives you the information that since what this server is up, and it also gives you the load average. So load average, it gives you the 1, 5 and 15 minutes intervals. We also understood that what is the load average. So it is the average number of processes which are actually waiting to run for a busy CPU. So they are waiting for access to the busy CPU, which are ready to run, but they are waiting for access to a busy CPU, right? And we also saw that it's a rule of thumb that if the load average is beyond the 3 times of the number of CPUs, it's a concern. The CPU is overworked. We also see the basics of top commands and how the top commands gives you the different types of data like CPU, memory, and the number of tasks running, right? Uh, Next, we saw that proc info, processor information command. So this command gives you the system data, which is inside the slash proc directory. So this is Linux specific command. If you move to the slash, if you have an hands on the Linux server, just move to the slash proc directory on your Linux. Just try to check if you can run this command. So this gives you the listed data like last boot time, load average again, the PID of the last process run, swapping information, memory resources on the server, number of disk, IRQ, installed modules, and file systems. Okay. Then we saw the different commands like rstat. So we also understood like what is rstat d. So rstat d is like an alternative for perf mode in the Linux environment or Unix environment. So it is remote statistics. So it is collecting the remote statistics from the server, and it is giving it to the all the data that has been obtained, uh, gathered by the kernel, gathered from the kernel. Okay, it's a daemon thread which is started by init d daemon. Okay, so what kind of information it provides? It gives you the collision rate, the paging rate, average load, swap out rate, the CPU utilization, and the disk rate. Okay, then we saw the SAR. Okay, so likewise rstat d is for the remote server, SAR is for the local host. SAR is system activity reporter, which gives you the everything on about your Linux or Linux box, everything whatever is going on your system at one place. So how the SAR works? SAR gives you the out file. The command I mentioned, that SAR hyphen capital E, it obtains capital A means all. You can also list out the specific counters if you want. So you just need to do man SAR in your Linux box, so you will you will get a list of available options. Okay, so you can first you can try to run with SAR hyphen capital A, and just don't give out file, just give the frequency. So every 5 seconds 2000 samples likewise. So you will see what are the different types of information this command can provide. And we can also have this daily report generated out of your Linux box or Linux box. So for that we need to do some changes in the cron tab, and the file that is already mentioned in the slide, like it is init.d/perf, and you have to use the reporting package. You have to use that reporting package, which is svc adm. Yeah, so this has to be activated, enable SAR. So that will reporting package will automatically report the information, and it will give you the daily data about your system. Okay, so same way the SAR command is there. So in the Solaris change service, the location is different. SVC system SAR default, which is the same keystat is kernel stats, that and the IOStat uses. Okay, we saw that other monitoring tools. What are the different other monitoring tools are there? So Quest Spotlight on SQL Server Enterprise. So SQL Server Enterprise has the Quest Spotlight tool, which gives you a very good amount of data about your SQL Server. Also, So it's the same alternative like for Oracle databases, you have Oracle Enterprise Manager. SQL, you have Quest Spotlight. Then VxStat utility for HP UX OS, middleware agent in HP's OpenView network management. Nowadays, they have some different solution for that. We see the performance agent. We already know about it, and that's it. So we will see some few other things tomorrow. The tomorrow's slide will be very much interesting, I hope. Okay, so that's all for today's session, Shano. I hope that the quick revision will help you guys to understand. Okay,
Yeah, thank you.
thanks. Oh, I will conclude the session today. Same to you, Anil. Thank you.